So far, all of the examples that we've looked at, the substitution that we've made has worked out just right. And in this video, we're going to start to see some examples of what happens when it doesn't work out just right, and we need to make some adjustments. So let's start with example 4 here. We have the indefinite integral of t cubed plus 4 raised to the 10th power times t squared dt. So this is most definitely an integration by substitution problem. I can tell because I have a function inside of another function right here. I've got t cubed plus 4 being raised to the 10th power. If you tried to do this using just your regular old power rule, you'd be in a lot of trouble. So this is definitely a good candidate for substitution. So I'm going to take and quote inside function just like I have in all of my other examples. I'm going to start by picking out an inside function, and I think the inside function for this problem should be t cubed plus 4. So off to the side, we'll say u is equal to t cubed plus 4. Once I have u, your next step is immediately to find du, which du is just the derivative of our u. So the derivative of t cubed plus 4 would be 3t squared. And then we need to multiply that by dt, t being our variable here instead of x. So we have our u and we have our du, and now we need to check and make sure that everything's going to line up exactly like what we'd like. So we already picked out the t cubed plus 4, and we said that's going to be our u. And if we start to think ahead a little bit to what our substitution is going to look like after we perform it, we'll have the indefinite integral of u. The 10th power is still there. It's u to the 10th power. And I need to now accommodate for this t squared dt. How am I going to deal with that? Well, if I look at my du in this case, I have t squared dt, which is good. That's good news. But I also have this extra 3 that it doesn't appear in my indefinite integral at all. So what that means is the substitution doesn't line up exactly right, like I'd like it to. That means I'm going to have to make some adjustments. So first of all, we're going to see what do we have left over in our integral besides the u. And in this case, it's the t squared dt. So that means in my du, I just want that t squared dt. So we said the 3 was extra. I'm going to get rid of that 3. And luckily, it's not too hard to do it. Since this is an equation, well, I can multiply or divide both sides by the same number. It's still equal. So I'm going to divide both sides by 3 would probably be your initial guess. But for reasons which I'll explain in just a minute, instead of dividing by 3, I think it's actually easier to multiply both sides by 1/3. It's still going to have the same effect. It's still going to cancel out that 3. And on the left-hand side, we'll have 1/3 times du. And on the right-hand side, we're just left with a t squared dt, which again, that's the piece that I want. So the t squared dt, that matches up exactly with what we have in our indefinite integral, which means when I take out the t squared dt, that means I'm going to replace it with 1/3 times du. That's the piece that's going to go right there. So I'll have u to the 10th times 1/3 du. So we were still able to make our substitution. We just had to do a little bit of adjusting here by multiplying both sides by that 1/3. Now the reason I suggested we multiply both sides by 1/3 instead of dividing by 3 is that 1/3 is a constant multiple here. 1/3 is a constant multiple, which means I can just go ahead and factor that to the front of my indefinite integral, and that means I won't have to worry about that fraction part of it. So I'm going to do that in my next step. Let's factor out that 1/3, and that will give us 1/3 times the indefinite integral of u to the 10th power du. And this now is much more manageable. It's a lot easier for us to integrate here. We can just use our regular old power rule. And again, after we perform that integration, we should end up with something that looks a lot simpler than what we started with. That's kind of the whole point of this integration technique, is we start with something that's hard, that's complex, and we see if we can simplify it and make it a little bit easier. So let's go ahead and finish this problem up then. The 1/3, that's a constant multiple, means it's just going to come along. We're going to multiply our antiderivative by 1/3. Here, u to the 10th du, we're going to use our power rule, so adding 1 to the power will give us u to the 11th power, divided by my new power, which is 11. I've done my power rule, so that means I need to add my constant of integration c. And then after this, there's just a little bit of simplifying that needs to be done. I'm going to go ahead and multiply these two fractions. 1 times u to the 11th, well, that would just be u to the 11th power. And then 3 times 11, if I multiply straight across, my denominator should be 33. And then, of course, we can't forget about our plus c. And then for the last step, just like we were doing before, I'm going to take that original expression that I picked out for u, t cubed plus 4, and I'm going to plug that back in. So I should have t cubed plus 4 raised to the 11th power divided by 33 plus c, and there is my general antiderivative. So in most cases, in most of the problems that we'll see, the substitution won't actually line up just right, and that's not the end of the world. We're just going to have to do a little bit of multiplication or division to make some adjustments. I want to look at one more example in this video. So here we have the indefinite integral of t cubed divided by t to the 4th minus 2 raised to the 5th power times dt. So I would encourage you to pause this video and see if you can kind of look back at the last example and see if you can kind of get this set up. Pick out your u, find your du, see if we need to make any adjustments, and try making that substitution. So pause the video for a minute, just try and make the substitution, stop right there after you've made it, and then we'll check our answer here in just a moment. So I think for this problem, your u is going to be t to the 4th minus 2. So u will be t to the 4th power minus 2. Du, remember du is just the derivative of your u. So in this case it would be 4t to the 3rd power times dt. So what do we have here? We've got this piece right here. This is my u. So if I think ahead to what my substitution is going to look like again, that u to the 5th is going to be in the denominator. And I think about, what do I have left over? Well, I've got t cubed dt. I'm multiplying those two things, even though they're not right up against each other. It's all just multiplication happening here. So t cubed times dt. So if I look at my du, I have the t cubed dt, which is good. I need that. But I also have this extra 4 that I need to get rid of. So just like I did last time, I could divide both sides by 4, but just to make the factoring process a little bit easier coming up, I'm going to multiply both sides by 1/4. So that means that the left-hand side will have 1/4 times du is equal to t cubed dt. So now I have the t cubed dt that matches up exactly with what we've got right here. Oops, let me circle it so it's a little bit easier to see. There we go. So that means when I take that piece out, I'm going to replace it with 1/4 du. And you can put that if you want. You can put that off to the side. You can say times 1/4 du. You can write it like that, which means we would need a 1 in our numerator. Or you can just put the whole darn thing in the numerator too. We could say 1/4 times du, although this does, I will say, it does kind of look a little messy with the 1/4, the fraction inside of a fraction. Let's put it off to the side. Times 1/4 du. We need something in our numerator, so it's got to be a 1. So this is what our function looks like after we've made our substitution. So what do we have left to do at this point? Well, we need to take this 1/4 and factor that to the front. So 1/4 times the indefinite integral of 1 over u to the 5th power times du. And now if I look at this, I can't integrate 1 over u to the 5th. I can't use my power rule while that variable lives in the denominator. So we got to rewrite it using our exponent rules. We'll have 1/4 times the indefinite integral u to the -5 power du. And notice I haven't added 1 to the power and divided by the power, so that means I still need to integrate. So that should be my next step. 1/4 times adding 1 to the power will give me u to the -4 power divided by my new power of -4 plus my constant of integration c. I'm going to multiply straight across right here, so 1 times u to the -4 power will be u to the -4 power divided by 4 times -4 would give me -16 plus c. And then after that, we're just going to take our t to the 4th minus 2 and plug that back in. So t to the 4th minus 2 raised to the -4 power divided by -16 plus c. Or if you want to rewrite that without negative exponents, we can say that's 1 over -16 times t to the 4th minus 2 to the 4th power plus c. Either one of these would be fine as your solution. So this is our general antiderivative. As we'll see a lot of examples coming up in the next video too, where we need to make adjustments, and most of those adjustments are not going to be too bad. As long as we just need to multiply or divide both sides by a constant, then we're going to be okay. We can make that adjustment no problem.